So this is the first video for chapter 4, which is all about inequalities. So in this one, we're going to review what the symbols are, how to write and graph inequalities. It goes with section not 4.12, 4.1 in the book. So look there if you're looking for a few more examples or notes or things. So there's 3 targets to write down. Make sure these are on your paper. We need to understand what all of these symbols mean, also the ones that have the lines under them like that. We need to be able to compare numbers using those symbols and write and graph inequalities. So there's some vocab to write down. First of all, what is an inequality? Well, inequality means not equal. So if they were equal, we would have an equation. But if they're not equal, we get an inequality. And we use these 4 symbols. So we have a greater than, less than, greater than or equal to, and less than or equal to symbol that we'll go through in a lot more detail, but you've probably seen them before. You also need to know what it means to have a solution. We had solutions when we did chapter 3, solving equations. Well, we still have solutions now when we solve inequalities. So a solution is a number or a value that makes it true, a number that works. So you're going to be able to solve inequalities just like we did with with equalities. The next one is a solution set. So now with inequalities, you might get more than one number that works, or a whole set or group of all the solutions that work. So in inequalities, and especially, you'll get more than one answer that's a possible solution. So we just group them and say the whole set of all the numbers that work make up a solution set. And this last one we talked a little bit about in chapter 3 as well. Substitution. That means to take a number and plug it in for a variable. So if I had something like this equation here, y equals 2 plus x, and they tell me that x is equal to 5, I could substitute it in and plug it in and end up with 2 plus 5, and then I would be able to tell that y was equal to 7. So that's substitution. When you take a value that they give you, plug it in for the variable, and then keep working it out. Okay, so you have the symbols written down on your paper. We're going to sort all of these different words to the symbol that they match up with. So you probably recognize this word, this name, more than, or greater than would be another way to say it. That would go over here. I'll put both of them. Greater than, more than, goes with this symbol. Okay. And we'll go through lots of examples showing you how these make sense and how they work. Okay, the one over here, less than or fewer than. Those would go together with that symbol, so you can write those down. And then with the ones with the lines under them, I have less than or equal to, and I have greater than or equal to. So there's a few more words here that we're going to continue to sort. Let's work through these. If I say no less than, so if I say you have to score no less than 90 points on the next test. Well, that means I could get 90, or I could get anything higher than 90, but not anything less than that. So that would match up with this over here. Bigger than 90 is good. 90 even would be okay, but nothing less than that. How about no more than? So you can eat no more than 2 pieces of cake. You could eat 1, you could eat 2. Okay, so sorry, I got interrupted. Let's go back. I think we were maybe talking about this one, no more than. You can eat no more than 2 pieces of cake. You could eat 2, you could eat 1, something less than 2, but no more than that. So it would go with less than or equal to. How about at least? Well, at least, you have to have at least 25 points in the game to win. Well, I need that many or more. So that many or greater than or equal to. At most would go over here again. Like you can have at most 5 friends over. Well, you could have 2 or 3 or 4 or 5, but no more than that. So 5 less than or equal to 5. Maximum and minimum. These ones get a little confusing. A maximum. That means it could be smaller than that, but it can't be any bigger. So I'd put that back over here again with less than or equal to. And then minimum means that's the lowest it could go. Could be something higher, but this is the minimum. So it's greater than or equal to that. So make sure you have all these words written down on your paper, where they go. And let's try a couple examples. So we need to be able to look at the symbols and understand what they're saying. Okay, we know the names of them now, but what do they really mean? Well, let's do an example for each one. I could give an example and say 7 is less than 9. Okay, that would work for using this symbol, and I read it from left to right. 7 is less than 9. This symbol, the bigger side is always going to eat the bigger number. Helps you put it in the right way. Or I could say 10 is greater than 5. Again, I read it from left to right. This is the greater than symbol, and again, the bigger opening is going to eat the bigger number. So write these examples on your paper as well, right, with the symbols. Okay, greater than or equal to is this symbol. So I could say something like 12 is greater than or equal to 6. That would work, but I could also say 12 is greater than or equal to 12, because then they're equal. And same thing over here, this is still the less than symbol. 17 is less than or equal to 20, but I could also say 17 is less than or equal to 17, and that could also be true. So this is a diagram or a chart that's in your book if it helps. You can copy it right out of your book or look there if you get confused too. Okay, so there's a space for you to write these, A, B, C, and D. We're going to talk about each one and make sure we understand what it means. So you are in at least 5 of the photos. So you could be in 5, or you could be in 6, or anything bigger than that. So if I translated this into an inequality, we would say that x is greater than or equal to 5, right? At least was our clue that we're saying greater than or equal to. How about this one? The temperature is less than -4 degrees Fahrenheit. Well, it's not -4 because it has to be less than that. I'm talking negatives now. So when I say less than -4, it has to be more negative. That would work, or that would work, or that would work. So my inequality would be that the temperature is less than -4, a smaller value, bigger negative. More than 3 students from our school are in the chess tournament. So not 3, it's more than 3. 4 or 5 or 6 would all work. And if I translated that into an inequality, I could say the number of students in the chess tournament is greater than, more than 3. Okay, and what about D? The balance in a yearbook fund is no more than -5. You can't have a bigger balance than -5. So it could be -5 or no more than that. So things that are smaller than -5. So if I wrote that as an inequality, I would say that the balance could be anything less than or equal to -5. So now we're going to do a little bit more with writing inequalities. I'll do a couple and then you can try a few. So there's 7 total. First one, a number x is at most -10. So we start with the variable on the left-hand side, read it, and decide what symbol to put in. At most. It could be smaller, it could be that many, but it can't be anything bigger. At 10, -10 is at most. So it's less than or equal to -10. Number 2, twice a number y is more than -5/2. Well, let's think about twice a number y. We did this in chapter 3. If I want to take twice of something, I would multiply it by 2. So 2y, I always write the variable on the left, write it first, is more than, so the greater than symbol, -5/2. Okay, I'll do one more and then you do the rest for practice. 4 less than n is at least 12. Well, 4 less than n would be starting with n and taking 4 away, and that's at least. So it's bigger than that. It could be equal to it, but equal or bigger, 12. Okay, just make sure your variable is always on the left. Okay, so try 4 and 5 here. Pause, write your answers down, and then you can we'll go over those and then do 6 and 7. So for this one, a minimum of 10, you have to spend, this is what you spend, has to be greater than or equal to 10. Or the prize, the maximum prize is $100. It could be up to $100, but not anymore. That's the maximum. So the prize is going to be less than or equal to $100. So here's number 6 and number 7. Pause and try those so we can check. So here's what I got. They should be written on your paper. Greater than, I turned into this symbol. Less than was that symbol. And just make sure your variable is always on the left-hand side. It should come first as you read it from left to right. Okay, so the next section is, now we're on the back, is telling whether something is a solution. This says, tell whether -3 is a solution. Well, we said it's a solution if it works. So we got to check and see if -3 would work here. So I'm going to rewrite it where I have a little bit more room. I'm going to use substitution. If I plug this in for the y, it would say -3 plus 6 is less than 4. Keep working it out. I'm just doing the math here. -3 plus 6 is 3. And if 3 is in fact less than 4, which it is, I say yes. It's a solution. It works. If I plug -3 in there, it would work. So yes, -3 is a solution here. Okay, how about this one? Well, leave the problem or recopy it. Then I'm going to take my -3 and substitute it in for the variable. So -3 over -4 greater than 4. The negatives here would cancel out, but I would still get a fraction. 3/4 is greater than 4. Is that true? No, it's not. So if it doesn't work or it's not true, then you say no, it's not a solution to that one. Okay, we'll do one more and then you can practice. Tell whether -2 is a solution of each inequality. There's room on your paper to just plug it in. So substitute it in for the variable. Do the math. -2 minus 5 makes -7. Copy everything down. Is -7 greater than or equal to -6? No, it's actually a smaller value. It's a bigger negative, but a smaller value. So you'd say, no, not a solution. Okay, so then B, and then tell whether -5, the next one's on your paper. Actually, there's 3 of those. Do those as practice. Substitute it in. So substitute in the -2, work it out, see if it works or not, and then your answer is yes, it is, or no, it's not a solution. Pause, and then we'll check. Okay, so check here. I plugged it in, worked it out. 11 is less than 14, so yes. And then down here, plug it in, work it out. 7 is not greater than 7. They're equal to each other, but it's not bigger than, so no. Here I get 11. Do the work, check your work. 11 is less than or equal to -9. No, that's not true, so not a solution. Careful here with your negatives. I got a -10, and then minus a negative actually turns into adding. And then this one, I get -2 is greater than or equal to -3. Yeah, it's closer to 0. So yes, it is a solution here. So the last thing to go over is how to graph them. And I hope that this is a review, but we'll talk about it together. So graph P is less than -3. So when I have to graph less than -3, that would mean it would include -4, -5, -6, everything over here. But it does not include -3 itself, just the thing smaller than -3. So I need to leave an open circle saying not actually -3, but just everything this way would work. So when you see a less than or greater than, it's going to be an open circle. The next one, I think you have to fix this one on your paper. Make sure this is the symbol that you see on yours. X is greater than -1. So this would work, this would work, this would work, but not actually -1 itself. So open circle and anything this way. Then I have Z is greater than or equal to 4. So Z can be 5 or 6. It could even be 4 or 5 or 6. So when it does include -4, I close the circle and show anything this way would work. And then S is less than or equal to 1.4. So find 1.4 would be about here. And anything smaller than that, including 1.4 and anything smaller. So I show my arrow that way. Real quickly, your book will show you this. If you're not sure which way the arrow should go, test a point and see. Test a point over here. If this point or any of these points work, then your arrow goes this way.